Hello everyone, welcome to my channel ICSE Topper Classes. Today we are going to discuss chapter 14 Theorems on Area exercise 14 question number 11 to 17 of M.L.aggarwal class 9 mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel. Now let us solve here 11th first part. In the figure given below, ABCD is a parallelogram. Point P and Q on on BC trisect BC into three equal parts. Then prove that area of triangle APQ is equal to area of triangle DPQ. So for proving this, firstly we will draw R and S from P and Q. So let us draw here to form a parallelogram here. So here it will be R and this will be S respectively, R and S respectively. Here we can see that triangle APD is equal to triangle AQD. Triangle APD is equal to triangle AQD because both are on the same base and between the same parallel lines. Hence both triangles are equal here. Now in this, letting it as first, we will subtract here from both sides, subtracting triangle AOD from both sides. We will get APD minus AOD is equal to triangle APO is equal to AQD minus AOD will be QOD. So triangle QOD. Now here we will add again POQ. Adding triangle POQ from both sides, we will get here triangle APO plus POQ is equal to triangle, here this is area of triangle, here also this is area, and here we can write area of triangle APQ. APQ is equal to area of triangle DPQ. From here only we can see, as this is proved here, the first two parts which is given area of triangle APQ is equal to area of triangle DPQ. And here we can see this triangle APQ and is on the same base of PQ parallelogram PQRS and between the same parallel lines. So we can write area of triangle APQ is equal to 1/2 of area of parallelogram PQRS, because PQRS forms a parallelogram. So here it is PQRS. Now we will simply find the ratio of area of parallelogram ABCD and area of parallelogram PQRS. So here area of parallelogram ABCD divided by area of parallelogram PQRS, and the formula of area of parallelogram is base into height. In ABCD, base is BC here, BC into height, let the height be h, and here in PQRS, PQ is the base and let the height be h. Here we can write, because BC is equal to 3PQ, because here it gives that in the question that BC trisect P and Q on BC trisect BC into three equal parts. So simply here we can write it as BC into H divided by 3, or simply we can write it as 3PQ. Firstly 3PQ into height divided by PQ into height. Height and PQ will be cancelled out and this will be equal to 3. Hence area of parallelogram PQRS is equal to 1 by 3 area of parallelogram ABCD from here, and we can write by using here area of triangle APQ is equal to area of triangle DPQ, and area of triangle APQ is equal to half of area of parallelogram PQRS. We can write here area of triangle APQ is equal to area of triangle DPQ. Hence it is given that is APQ is equal to half of area of parallelogram PQRS, means In the place of area of PQRS, we can write 1 by 3 area of parallelogram ABCD. And from here only we can prove which is given in the question. So it is area of triangle APQ is equal to area of triangle DPQ, and this is equal to 1 by 6 area of parallelogram ABCD. Hence proved from here. This is only we have to prove in this question, and this is the solution of this question here. Now let us solve question number 11, second part. In the figure given below, DE is drawn parallel to the diagonal AC of the quadrilateral ABCD here in this diagram to meet BC produced at the point E. Then prove that area of quadrilateral ABCD is equal to area of triangle ABE. So as we have this AC as the base, and two triangles ADC and AEC are on the same base and between the same parallel lines. So we can simply say that area of triangle ADC is equal to area of triangle AEC. So because both triangles on same base and between the same parallel lines. And in this only we will add in the first equation. Now adding triangle ABC on both sides, we will get here as in triangle ADC on the first equation, ADC plus ABC is equal to area of triangle ABC plus area of triangle ADC. Again here area of triangle AEC plus area of triangle ABC. So we can simply write it as area of triangle, area of quadrilateral, sorry, because ABC plus ADC is, forms a quadrilateral ABCD. So area of quadrilateral ABCD from here is equal to area of triangle ABE, and this is only we have to prove in this question, hence proved from here, because area of quadrilateral ABCD is equal to area of a triangle ABE, hence proved here. Let us solve here 11 third part. In the figure given below, ABCD is a parallelogram. O is any point on the diagonal AC of the parallelogram. Then show that area of triangle AOB is equal to the area of triangle AOD. So, to prove this, we can simply draw a diagonal joining B and D here. And as we know, the diagonals of a parallelogram bisect each other. Means here they will meet at P, and here AP is equal to CP and DP is equal to BP. Hence, we can say in triangle ABD, AP is the median. And from here only we can write area of triangle ABP is equal to area of triangle ADP, because the median divides a triangle into two congruent triangles. Now, from here we can write, similarly we can write that in triangle DCB, CP is the median, and because BO and DO are of the same length from the corner points, as AC is the diagonal here. So simply we can write here in triangle PB, area of triangle PBO, because OP is median here also. So area, this is equal to area of triangle PDO. Putting it as first and second. Now we will, now adding first and second equation, we will get here area of triangle ABO is equal to area of triangle ADO, and this is only we have to prove in this question, hence proved from here. Now let us solve here 12th first part. In the figure given below, ABCD and AEFG are two parallelograms. Prove that area of parallelogram ABCD is equal to area of parallelogram AEFG. So here we can simply firstly join BG to prove that triangle ABG is equal to half of parallelogram ABCD because it is on the same base and between the same parallel lines. So here area of triangle ABG is equal to 1 by 2 area of parallelogram ABCD. Put it as first. Now we have area of triangle ABG is equal to half of area of parallelogram AEFG. Put it as second equation here. Now, to prove that these two are equal, we can simply see that area of parallelogram ABG and area of parallelogram ABG is equal to half of area of parallelogram ABCD and half of area of parallelogram AEFG. So, from first and second, we can write here half of area of parallelogram ABCD is equal to half of area of parallelogram AEFG. This will be cancelled out and it will be area of parallelogram ABCD is equal to area of parallelogram AEFG. And this is only we have to prove in this question, hence proved from here. Hence proved that ABCD is equal to AEFG. Now let us solve here 12th second part. In the figure second here given below, the side AB of the parallelogram ABCD is produced to A. A straight line through A is drawn parallel to CE to meet CB produced at F, and parallelogram BFGE is completed. Then prove that area of parallelogram BFGE is equal to area of parallelogram ABCD. So we have to prove this. Simply here we can see that the two triangles ACF and AEF are on the same base AF and between the same parallel lines. So we can simply write here area of triangle AFC is equal to area of triangle AEF, and putting at first, now we will subtract here, subtract triangle ABF from both sides. On subtracting ABF, we will get as area of triangle AFC minus ABF is equal to area of triangle ABC, and area of triangle AEF is equal minus area of triangle ABF is equal to area of triangle BEF. Now we will put it as second and we will multiply the second equation with 2. So on multiplying we will get area 2 area of triangle ABC is equal to 2 area of triangle BEF. And as we know that the diagonals in a parallelogram divide it into two congruent triangles. So we can simply see here, if we draw AC here and FE, the two congruent triangles are equal, means 2 area of triangle BEF is equal to, here we can write this as area of triangle BEF plus FEG and area of triangle ABC plus DCA, because these two are equal and these two are equal. So from that only we can conclude area of parallelogram ABCD is equal to area of parallelogram BFGE, and this is only we have to prove in this question, hence proved from here. So this is the final solution of this question here. Now let us solve here 12th third part. In the figure given below, AB is parallel to DC and DC is parallel to EF, AD is parallel to BE here, and DE is parallel to AF. Prove that the area of DEFH is equal to the area of ABCD. So here we have, as we can see that ABCD is a parallelogram and DE, here this DAGE is also a parallelogram. So we can simply see that it is on the same base and between the same parallel lines, means ADEG and ABCD is a parallelogram which are equal by the theorem. Now secondly we have ADEG and DEFH on the same base and between the same parallel lines means these two parallelograms are also equal. And from these 1 and 2 equations, we can simply say that area of parallelogram ABCD is equal to area of parallelogram DEFH. Hence, proved from here that which we have to prove in this question, and this is only we have to prove. Here we are going to solve question number 13. Any point D is taken on the side BC of a triangle ABC and AD is produced to DE such that AD is equal to DE. Then prove that area of triangle BCE is equal to area of triangle ABC. Here we can simply see that BD is median and AD is equal to DE. So BD is median and BD of a any median of a triangle divides it into two equal triangles of equal area. So here we can write area of triangle BDA is equal to area of triangle BDE. Put it as the first equation. Now same thing here, as AD is equal to DE, then CD is the median of a triangle ACE. Hence triangle ADC, area of triangle ADC is equal to area of triangle DCE. So again we can write area of triangle ADC is equal to area of triangle DCE. This is the second equation here. Now on adding first and second equation, we will get here 8 and area of triangle BDA and area of triangle ADC is equal to area of triangle ABC. And here area of triangle BDE is equal to area of triangle DCE. If we add that, we will get area of triangle BCE. So this is the final thing which we have to prove in this question. Hence proved from here. Hence proved. Now let us solve here 14 question. ABCD is a rectangle and P is a midpoint of AB. DP is produced to meet CB at Q. And we have to prove that area of rectangle ABCD is equal to area of triangle DQC. So this we have to prove. For proving this, we can take here triangle. In triangle APD and triangle PQB. So here we can take it as, because AP is equal to BP, as P is the midpoint of line AB, and here we have angle DAP is equal to angle QBP because they are of each of 90 degree because it is a rectangle. So DAP is equal to angle QBP because each is of 90 degree, and this is given to us here in this question. And angle APD is equal to angle QPB because they are vertically opposite angle. So here we can write angle of APD is equal to angle of BPQ because they are vertically opposite angle. From that only we can prove that triangle APD is congruent to triangle BQP by angle side angle rule of congruency. We have proved here. And as two triangles are congruent, area of triangle is also equal. So area of triangle APD is equal to area of triangle here BQP. And from that, area of rectangle ABCD is equal to area of triangle APD plus area of here quadrilateral PBCD. And as here BQP, here BQP is equal to APD. Instead of APD, we can write here BQP. So area of triangle BQP because these two are equal, and area of quadrilateral PBCD. From that, we can simply write it is equal to area of triangle CQD. Sum of these two is triangle CQD. Hence proved here, which we have to prove, area of rectangle ABCD is equal to area of rectangle CQD. This is only we have to prove, hence proved from here. And this is the solution of the 14th question. Let us solve here 15 first part. In the figure given below, the perimeter of parallelogram is 42 centimeter. Calculate the length of the sides of the parallelogram. So here we have, let AB firstly P and Here perimeter is given, and the perimeter formula of a parallelogram is 2 AB and BC, the alternate sides. So we can simply write it as perimeter of parallelogram is equal to 2 AB plus BC. So here we can write 42 is equal to 2 AB plus BC, and AB we can write it as P. So 42 divided by 2 is 21 equal to P plus BC, and we can write BC as 21 minus P. So BC is equal to 21 minus P from here, and here area of parallelogram we can write as the formula of area of parallelogram is base into height. Firstly we can take here AB into DM. Here we can put the value AB is P and DM is given as 6. So it is equal to 6P from here. Again we have area of parallelogram. We can write it in a different way as BC into DN. And DN is given to us. BC is 21 minus P from here. So 21 minus P into 8. We will put the value here. 6P is equal to 168 minus 8P. 6P plus 8P is equal to 14P, and this is equal to 168 from here. We will divide it, and P is equal to 12 from here. Means the side AB is equal to 12 and the side BC is equal to 21 minus 12, which is equal to 9 from here. So this is the final answer here in this question. 15 first. Now let us solve here 15th second part. In the figure given below, the perimeter of triangle ABC is 37 cm. If the length of the altitudes AM, BN and CL are 5x, 6x and 4x respectively, calculate the length of the side of triangle ABC. Here, firstly we will let BC is equal to P and CA is equal to Q. As perimeter is given to us, and in a triangle the sum of all the sides is equal to perimeter. So AB plus BC plus CA is equal to 37. From here we can find the value of AB as 37, BC is minus P we can write, and minus Q. So this is the value of AB from here. Now as we know, area of a triangle is half base into height. So we can write here half into BC into AM, and this is equal to half into AC into BN. This is equal to half into AB into CL. Now we will put the value of BC here. BC is equal to P, so BC into AM. AM is equal to 5x here. It is given to us 5x. Now equal to half AC. AC is Q and BN is equal to 6x from here. Now we have AB as 37 minus P minus Q into CL is equal to 4x from here. We will divide it. It will be cancelled out, and here 3, here 2. So from here we can cancel out x from all 3. And now we can simply write 5P by 2 is equal to 3Q. This is equal to 37 minus P minus Q into 2. Now firstly we will take the first 2, so it will be 5P by 2 equal to 3Q, and from here we can find 5P equal to 6Q, and 5P minus 6Q is equal to 0. Put it as the first equation from here. Now the last 2 we will take. From here we can get 3Q is equal to 74 minus 2P minus 2Q. 3Q plus 2Q plus 2P minus 74 equal to 0. So this is the equation formed. 2P plus 5Q minus 74 is equal to 0 from here. Put it as the second equation here. Now from here we will multiply this part with 5 and this part with 6. So on multiplying we will get here 25P minus 30Q is equal to 0, and here 12P plus 30Q is equal to 444. This will be cancelled out from here, and it will be 37P on adding equal to 444. Now we will just divide it. 444 divided by 37, and from that on cancelling we will get here as 12. Now we can find the value of Q from here. So 5P minus 6Q is equal to 0, means 6Q is equal to 5P. P is equal to 12, so 5 into 12 is equal to 60, and 6Q is there. This will be cancelled out and q is equal to 10 from here. And p is equal to 12. As p is equal to 12 and q is equal to 10 here, we can simply found here AB. AB is equal to 37. Here AB is equal to 37 as we have calculated, minus P minus Q means 37 minus 12 minus 12 is equal to 15 centimeter from here. AB we have found, BC is equal to P, so it will be 12 centimeter, and CA is equal to Q means 10 centimeter. So this is the final answer which we have to find. So this is the answer here in this question, and this is the solution of 15 second part here. Now let us solve here 15 third part. In the figure given below, ABCD is a parallelogram. P is a point on DC such that area of DAP is equal to 25 centimeter square and area of triangle BCP is equal to 15 centimeter square. Then find area of parallelogram ABCD. Here ABCD is a parallelogram and P is a point on DC. So we can say that area AB is ABP and parallelogram ABCD is on the same base and between the same parallel lines. So by theorem, area of triangle ABP is equal to half of area of parallelogram ABCD, and half of parallelogram, because ABP is half of parallelogram ABCD, means the remaining one DAP plus BCP is equal to half of parallelogram ABCD. So we can simply write area of triangle DAP plus area of triangle BCP is equal to, by diagram we can see, 25 plus 15, which will be 40 centimeters square. So from that we have got half of area of parallelogram ABCD from here, and as this is equal to 40 centimeter, means area of parallelogram ABCD. From here we can write it as 80 centimeters square is the final answer here in this first part. Now we have to find the value or ratio of DP ratio PC. As we have DC is equal to DP ratio PC, so we can simply say that these two triangles are on the same base and between the same parallel lines, means the ratio of their area is equal to the ratio of their bases. So we can simply write DP by PC is equal to, firstly we have area of triangle DAP and now area of triangle BCP. So we'll put the value here. This will be 25 by 15. So from here it will be 5 ratio 3 is the final answer here in this question. So this is the solution of 15 third part. Let us solve 16 question. In that joining figure, E is the midpoint of the side AB of a triangle ABC and EBCF is a parallelogram. Means if EBCF is a parallelogram, EF is parallel to BC and E is the midpoint. Then G is also the midpoint of line EF. So if G is the midpoint here of AC, because it is a triangle ABC by midpoint theorem. So we can simply write AG is equal to GC and angle EAG in the triangle CGF and EGA. Angle EAG is equal to angle GCF because they are alternate angles. And now angle EGA is equal to angle CGF because they are vertical opposite angle. So from that only we can say that triangle EAG is congruent to triangle CGF by SAS rule of congruency. So from that we have proved that these both triangles are congruent. So from that we have area of parallelogram EBCF is equal to area of here this is quadrilateral, so area of quadrilateral BCEG plus area of triangle CFG. And as CFG is congruent to EAG, we can write area of quadrilateral BCEG plus area of triangle EAG, because if the two triangles are congruent, then area is also equal of both the triangles. Now we can write area of parallelogram EBCF is equal to area of triangle ABC, hence proved from here. So hence proved. This is the final answer solution of this question. Let us solve here 17 first part. In the figure given below, BC is parallel to AE and CD is parallel to DE. Then prove that area of triangle ABC is equal to area of triangle EBD. So to prove that, firstly we will join AC and CE. From that we have BC as the same base and between the same parallel lines. So we can say that area of triangle ABC is equal to area of triangle here ECB. As both are equal, so we can simply write here from EBC and EBD. We have the same thing, EBC and EBD, if we take that both triangles, because they are on the same base and between the same parallel lines. So area of triangle here also EBC is equal to area of triangle EBD. So from this first and second, we can conclude that area of triangle ABC is equal to area of triangle EBD, and this is only we have to prove in this question, hence proved from here. Now let us solve 17 second part. In the figure given below, ABC is a right angle triangle at A and AGFB is a square on the side AB and BCD is a square on the hypotenuse BC. If AN is perpendicular to ED, then prove that triangle BCF is congruent to triangle ABE. Area of a square ABFG is equal to area of rectangle BENM. For proving this, firstly from diagram, we will take angle FBC. Angle FBC is equal to FBA plus angle ABC, and FBA is equal to 90 degree because this is a square plus angle ABC. Again in triangle ABE we have angle ABE, we have angle CBE plus angle ABC, and angle CBE is equal to 90 degree because this is a square. Now from these first and second only we can prove that angle FBC is equal to angle ABE, and BF is equal to, here this BF is equal to AB because these are the sides here of a square only. So BF is equal to AB and BC is equal to CE, as BCD is a square. So triangle BCF is congruent to triangle ABE from here, hence proved. So hence proved that this is a uh, triangle are congruent, and as these triangle are congruent, we can similarly prove the second part by the help of this only, that area of triangle BCF is equal to area of triangle ABE because these are congruent, and from that only area of triangle BCF, because it BCF and AGFB is on the same base, AB here is on the same base, FB sorry is on the same base or FB, and are between the same parallel lines FB and CG. So we can say that area of triangle BCF here is equal to half of area of square AGFB, putting it as the first part. And again we have area of triangle ABE is equal to half of area of rectangle BENM. So this is the second part here. And now from the first and second part only we can prove that these both are equal because area of BCF is equal to area of ABE from this part. So these two are equal, and half area of square AGFB is equal to half area of rectangle BENM. Now this part will be cancelled out, and from that only we can prove that area of square AGFB is equal to area of rectangle BENM, and this is only we have to prove in this question, hence proved from here. So hence proved from here, and this is the solution of this question here in this video. This is the solution. Thank you for watching my video. If you like this video, please like, share and subscribe my channel.